Hi folks, this week we're going to cover chapter 6 on weathering and soil in our geology class. So these are external processes on the earth. We have weathering and mass wasting and erosion. And so weathering is the physical breakdown and chemical decomposition of rock. Mass wasting is the transfer of rock and soil downslope under the influence of gravity. And then erosion is the physical removal of material by water, wind, ice, or gravity. And so there are two types of weathering. We have mechanical weathering, which is the breaking of rocks into smaller pieces. And these can include frost wedging, where ice gets locked into the rocks and freezes and changes the density of the rock. Unloading and thermal expansion due to heat or cold. And biological activity inside the rock. The other type of weathering we have is called chemical weathering, and this is breaking down of rock components and internal structures of minerals. And in chemical weathering, the most important agent is water. It's responsible for the transport of ions and molecules involved in the chemical processes. So these are the major processes of chemical weathering. There's dissolution, aided by small amounts of acid in the water. Most water is a little bit acidic. Oxidation, any reaction where electrons are lost from one element. And hydrolysis, the reaction of any substance with water. And a hydrogen ion attacks and repels other ions in hydrolysis. Alterations included with chemical weathering includes decomposition of unstable minerals, the formation or retention of stable materials, and physical changes such as the rounding of corners and edges. So in weathering of rocks and minerals, we can weather various minerals into other residual products. Feldspars, for example, can go into clay minerals used by silica, potassium, sodium, and calcium. Olivine can turn into limonite or hematite, and hematite is actually a material found on Mars. Factors affecting weathering include the surface area of the rock itself and the rock characteristics, including rocks that contain calcite, which is marble and limestone. They readily dissolve in weakly acidic solutions. The common test for limestone is to put a drop of hydrochloric acid on it. And silicate minerals, whether in the same order as their order of crystallization. So if you have a rock that starts off with 4 square units, it's got 6 sides to it, that's 24 square units. And you can see as it weathers down, you can see that the square units multiply and multiply and multiply together to get more and more of a surface area the smaller the rocks go. Well, there are different factors that go into the rates of weathering. One of those is climate, the temperature and moisture characteristics of the environment the rock is in. And chemical weathering is most effective in areas of warm and moist climates. Now we can also have differential weathering. This is where rocks do not weather uniformly due to regional and local factors. This may include height and depth of the rock. Results in many unusual and spectacular rock formations and landforms. And on your book, in page 175, is a picture of Arizona's Monument Valley. These rocks that are standing in the middle of nowhere, carved out by wind and water erosion. I was lucky enough in August of 2013 to go to Arizona and see this monument. It's very spectacular, especially in the late afternoon, evening time, the sun setting behind it. Very spectacular landform to see. So here is Bryce Canyon National Park in Utah, and you can see these formations that have been formed by weathering due to differential height. Beautiful aspect there. Let's regather our thoughts now and look at soil. Soil is mineral and organic matter plus water and air. Rock and mineral fragments produced by weathering of regolith, which is the soil, that support the growth of plants. And humus is decayed animal and plant remains, a small but a very essential component of soil. So here is the composition of what we call a good soil, maybe a soil suitable for farming. 45% of it is mineral material, 25% is mixed in with the air, and 25% is mixed in with the water below. 5% of it is organic matter, and that 5% is critically important. Factors that control the soil formation include the parent material, the residual versus transported soil on the surface, and time. The amount of time for soil formation varies depending on geologic and climatic conditions. The climate is important because it's the most influential control of soil formation. Key factors of climate include temperature and precipitation and moisture. The plants and animals nearby influence the soil's physical and chemical properties, along with the topography. The steep slopes often have poorly developed soils because of wasting due to gravity, and the optimum terrain is a flat to undulating upland surface. So here are variations in soil development. We can see the steep slopes have no soil development because of the very steep slope to it. Down below in the valley, they are transported soil development on stream deposited sediment. We see this along river banks in Missouri. And then higher up on the bedrock on a slope is residual soil deposited onto the bedrock. Let's look at the soil profile. A soil forming process operates from the surface downward, and the vertical differences are called horizons, which are zones or layers in the soil. The O horizon is the organic matter. The A horizon is the organic and mineral matter. It has a high biological activity, and the O and A horizons make up the topsoil, the very top layer of the soil. The E horizon has little organic matter. It's a zone of evolution and leaching, where we have lots of deposits being wasted away by erosion. The B horizon is a zone of accumulation, where sediments accumulate. And the C horizon has partially altered parent material, which may have gone through some evolution of erosion. Collectively, these horizons make up the solum, or the true soil, beneath. So here is the idealized soil profile, the O horizon on top and the A horizon below it making up the topsoil. E and B, C down below that into the rock material, the subsoil. Here again our soil profile looking at the different horizons we see in the soil between the topsoil and the soil beneath it. We can classify soils in different varieties. Variations in soil formation over time and distances have led to a great variety of recognized soil types. The groups have been established using common characteristics. And in the United States, a system was devised called the soil taxonomy. Emphasis on the soil taxonomy is placed on physical and chemical properties. There are 6 hierarchical categories existing. Descriptive names are derived from Latin and Greek alphabets. And the 12 basic soil orders are recognized. This is in your book. Also, you can find this in your chapter 6. Basic soil orders. Soil erosion. Part of the natural recycling of all earth materials is soil erosion. Natural rates of soil erosion depend on various categories such as soil characteristics, climate, slope, and the type of vegetation on top of it. So where the vegetation is lacking here, in a desert or plain, the soil erosion is very high. In many regions, the soil erosion is much greater than the rate of soil formation. And in this place, we have sedimentation and chemical pollution related to the excessive soil erosion. And occasionally, soil particles are contaminated with pesticides from downsloping farms. That's the end of chapter 6. That was a pretty quick chapter. Be sure to look at the discussion questions, your lab for this chapter, and the quiz. We'll see you next time.